This is the Armdroid. It's a robot arm, as you can probably tell, and it's quite old. I found this in my engineering teacher's closet a couple years ago, and it didn't work. So I've reverse engineered it and tried to make it work. So this is the Armdroid circuit board. A lot of chips on there, but none of them are processors. It's all combinational and sequential logic. The data comes in through this DB9 connector, and it is then buffered by these two bus buffers here. The latch line goes to this monostable, which is then routed through this demultiplexer controlled by 3 of the data lines to send the latch signal to the appropriate one of the 8 latch chips, which then latch the 4 data bits. The data bits are sent to these Darlington transistor arrays. The ones driving the motor have heat sinks on them, which then drive the motor. Power is provided by the input power connector, which is just a couple pins are positive, couple are negative, and then regulated down to 5 volts for the logic circuitry by this huge resistor and a voltage regulator. That's the entirety of the logic on the Armdroid control board. All of the waveforms, there's nothing there to generate the waveforms. And all the waveforms are generated by whatever's plugged into this DB9 port. But you can't use a standard serial cable if you have any of those lying around because it needs all 8 pins. So I had to make a custom cable, and then the end is plugged into an Arduino, which generates the waveforms. It's interfaced to the Armdroid using a serial setup with a shift register, specifically a 74164. The controllers are just 3 joysticks, so that's 6 inputs each. That one isn't used. And the Armdroid has, as I said before, a parallel interface, and I've set up the Arduino to only use 3 pins there, which is a serial interface. But it certainly has enough pins to drive it directly, and I did for a while until I found the shift register chip. Mechanically, the Armdroid is pretty simple. There's only 6 stepper motors, 5 of which are mounted on the shoulder. The 6th is mounted in the base to control the rotation. The 5 in the shoulder transmit the rotation up through the arm via a set of timing belts. One motor controls the elbow, one controls the shoulder joint, and then 2 motors drive the wrists in a differential setup. The last motor pulls a string that will close the claw. The original Armdroid had a very cool 3-fingered claw, and there was a second one broken in my engineering teacher's storage closet, but unfortunately the claw was broken, so I can't use it. The original Armdroid's power connector looked like this, but there was nothing in the closet along with it to connect to that power connector, so I modified it to use Anderson connectors that the old FTC team at my school had for their batteries, but are no longer operating, so I stole them. It's quite a slow robot. I guess it doesn't have very good grip strength, though, because they're using Velcro pads. Obviously, those have been replaced. There's the differential gear setup turning the claw. There's actually 2 motors running right now, and one of them is running a little slower than it should. As you can see, there's a considerable amount of backlash in the mechanism, which is one of the reasons why the Armdroid was not designed for precision work. The Armdroid did come with some accessories, one of which is this plexiglass turntable. As you can probably see, it's got the same setup in the base for turning it as the actual Armdroid does. There's a stepper motor, a belt, and a gear. Here's what the stepper motor looks like inside. All it is, there's no driver in here. The cord was intended to plug into the Armdroid. The last accessory is this screw slider. I'm having a little trouble fitting in the frame because it's so big. This was actually kind of interesting because I couldn't find any pictures of it online. It was mentioned in a few manuals, but I could not find any other mentions of it. As for what it is simply a platform that's moved by a screw that's then turned by a stepper motor on the end. There's a pulley system to increase the speed at the expense of resolution. Like the turntable, there's a cord that plugs into the accessory port on the Armdroid. One of the other things that came in the cabinet with the Armdroid was this extremely long conveyor belt. What makes it different from the other accessories is it has an integrated power supply. The inside of it is relatively simple. There's a stepper motor that turns the belt, there's a transformer to provide power, and then a simple circuit board that interfaces with the switch panel to control how fast the motor runs. That's all I have for the Armdroid. I made an entire website with more documents and pictures of this robot, and the code I used on the Arduino is on GitHub. The links are in the description. Hope you enjoyed this video.